In the next two lessons, we're going to look at the reactions of metals with acids. First of all, let's write down the general equation for this reaction. And in this case, we're talking about the reaction of a metal with a dilute acid, for example, such as diluted HCl. So we've got the metal plus an acid, and that's going to produce a salt plus hydrogen gas. Now, the type of salt that's produced depends upon the type of acid and the type of metal, and we'll look at that more in the next lesson. But first of all, we want to consider this general reaction in the context of the reactivity series, in the same way that we've just done with water. Now, the reactions of metals with acids go a lot more aggressively than the reactions of metals with water. And in fact, in the case of this reactivity series, you should never really add any of the first four elements, let's say potassium, sodium, lithium, or calcium, to a dilute acid, because the reaction could be explosive. So we'll put dangerous here. Danger. Possible explosion, yeah, explosive reaction. And then after that, between magnesium and lead, the metals react with decreasing reactivity, and this will be evident in the rate at which hydrogen is released. So as we move down this series, the rate at which hydrogen is released decreases as we get towards hydrogen. And then after hydrogen, well, these metals are no longer capable of reducing the hydrogen ion into the hydrogen atom and therefore a gas. So, as in the case of water, these do not react with acids either. Now, in the case of aluminium again, we'll just make this note. Aluminium again has a protective oxide layer, so in the case of cold dilute acids, it won't tend to react, but it will start to react as you warm up the acid. So I think it's on warming the acid. Okay, in the next lesson we'll take specific examples of the reactions between different metals and different acids to produce different types of salt.